Hello, good morning. I hope you can all hear me well. Warm welcome to everyone who joined us today. We have 107 attendees, which is quite a nice number. So thank you very much for your time and your interest in the topic of our webinar, which is Sustainable Bioenergy, a Circular Approach to Use Strategic Autonomy and Green Transition. So three very important topics: decarbonization, strategic autonomy and industrial strategy, and green transition. Let me remind you that this event is held under the umbrella of EU Industry Week 2021. We are a local event. And my name is Michał Długosz. I work as a policy officer in Bioenergy Europe. And today with me is also a team from Bioenergy Europe with Jean-Marc Jassard, Julia Kanchan, and Ines. This is also very important that this event is some kind of result of a cooperation within the bioenergy business between different research institutes and institutions. And at the time, I wanted to thank all these institutions for a very swift and fruitful cooperation. So our co-partners are International Energy Agency Bioenergy Technology Collaboration Program, the Center for Research and Technology HELLAS, Research Center for Energy Resources and Consumption CIRCE, Energy Efficiency in Industrial Processes EEIP, WIP Renewable Energies, European Technology and Innovation Platform Bioenergy, and FNR from Germany. So once again, thank you all for the joining forces to organize this event. And now I'll move to shortly describe how it will be structured. So during this webinar, we will discuss biomass contribution towards decarbonization of industrial processes, improvement of circular economy, as well as the increasing of resilience of the European industry. And the webinar will be divided into three parts. In the first one, we'll have two presentations, which will touch upon long-term alignment of bioenergy use in industry with climate modeling scenarios, and as well as particular uses of bioenergy use in industry. In the second, then we'll move to the panel debate with industry professionals coming from three among the most successful companies active in the business of bioeconomy and equipment manufacturing, which are Valmet, Stura Enso, and Renewable Invest. And the practitioners will provide us with information concerning production and industrial aspects of bioenergy use, also concerning its sustainability dimension. And then we'll move to Q&A session where you can ask questions. And at this point, I would like to introduce our speakers, our distinguished guest today, Eduardo Sembrano, Head of the Industry and Energy Department, CIRCE, Research Center for Energy Resources and Consumption. Luke Pelkmans, Technical Coordinator, IEA Bioenergy. This will be two presentations. And then in the panel, Michael Jugaste, Head of Quality and Certification System, Renewable Invest. Anna-Lisa Millinen, Head of Sustainability, Stura Enso Wood Products. And Karita Olikainen, Head of Corporate Relations, Valmet Corporation. And just before we restart the event, just small housekeeping announcement. So during the entire event, you can ask questions at any time using Q&A box. You will find on the bottom of the screen. Please keep questions relevant to today's topic, which is decarbonization of the industry, circularity, and strategic autonomy. And Julia will choose several questions which will be posed in the Q&A session. So basically throughout the whole event, you can ask your questions and there will be dedicated Q&A at the end. And during the event, there will be several two questions, which I hope will make it a bit more interactive. And now I would like to start the event with the first one. Just to check your attitude and your point of view at the beginning. In your opinion, how important is sustainable bioenergy in achieving the decarbonization of the European industry? Three questions: large untapped potential, it is a part of a solution, or it should not be considered at all. So you have 1 minute to answer. Okay, thank you. I think we can end polling. So the clear answer is it is part of a solution, 63%. Second answer is large untapped potential. I think this is the answer we are closer to, but still I understand. But still it received 35%, and 3% should not be considered at all. We also understand this perspective, and we are open for such arguments. And so thank you for voting. We can see that bioenergy may be a part of a solution. This is your first let's say ideas which comes to your mind, and we'll be happy to deliver many examples and show this solution in a perspective of a climate scenarios. And right now we move to the first presentation, which will be delivered by Luke Perkmans. Luke, the floor is yours. You can share your screen.
Okay, thank you, Michael. I will try to do that. Can you see my screen?
Yes.
Okay. All right. Thanks for the introduction, and also thanks for inviting me to give this introduction speech for this interesting workshop. So I'll give some first insights based on also work which is done at the IEA in Paris, but also some insights of a workshop that we had like half a year ago on this topic, and some conclusions that we had there. Just for people who don't know IEA Bioenergy, we're actually technology collaboration program. So it's really a body which is collaborating all over the world with different countries, and we're functioning within a framework created by the IEA, the International Energy Agency. So we're not part of IEA, but we have a close connection with it. And our goal is actually to collaborate internationally and to exchange information on bioenergy, what's going on in terms of research, on technology development, on demonstrations, also policies, and also try to facilitate market deployment of what we call sustainable bioenergy systems. So in terms of environment, socially, and also economics behind it. We have 3-year work programs with different tasks that you may have seen, also specific projects on topics. And you see a list also of the member countries that we have. So we are 26 countries at the moment collaborating in this. Now, going to some of the analysis which have been made by the International Energy Agency quite recently also. First, the results of their sustainable development scenarios. So it's actually a new scenario which they have calculated, an updated scenario also to look how can we really achieve carbon neutrality in the second half of this century. I think now the focus was in 2070. I think they're also doing calculations if this could be done earlier, but of course this is a global perspective. So it's not only Europe, but it's globally with the aim of going down as fast as possible. What you see here is the different sectors, the contribution in different sectors. And first thing you see is that the power generation is a very important part of this. So electrification is important, is already starting. You see a lot of progress with renewables in the power sector. You see also progress in electric cars. But if you add those two up, you're actually getting about 1/3 of the additional greenhouse gas savings that we need. So there also needs to be focus on other sectors like long distance transport, industry, buildings. So it's really not only about electricity, there's also other things that we need to consider as well. And so there's really a large portfolio of clean energy technologies which are needed. Kind of pedal to the metal is what they also say at the IEA. So we need to do what we have in our hands to reach that, which is starting with the demand side, trying to avoid demand which is not needed, with technology performance, so increasing efficiency. With electrification, again, a pretty important role also for electrification. But there's hydrogen, there's bioenergy, there's other renewables, there's other fuel shifts, and also quite important is carbon capture and storage or utilization. So if you look at the role of bioenergy in this whole portfolio to reduce greenhouse gas emissions, you come out to about 1/5, so about 20% is related to bioenergy. Either just bioenergy on its own, but often also bioenergy in combination with CCS, so carbon capture and storage, which in the end is providing negative emissions, which is clear that we will also need to compensate for some remaining greenhouse gas emissions. Also in this sustainable development scenario, they looked into, well, what is then the role of biomass and bioenergy in different sectors. You see them added on top of each other. So starting from actually the amount of biomass used today, like in 2019 is the starting figure. And there is an increase of, yeah, in this case, like a doubling that we would need on the long term. But if you look at the modern bioenergy types, the one on top, it actually needs to triple. So it's important in terms of traditional building where you have quite unsustainable and inefficient use of biomass. This is something that we need to phase out. So we have to go to more modern heating. But on the right side of the figure, you also see there is an increasing role of bioenergy in industry, kind of a doubling. There's a very much increasing role of biofuels in transport, I think quadrupling. And that's mostly focused, well, on the short term it's focused on road transport, but longer term it's also focused on the long distance like aviation and marine. You see important role also in power generation, and with very important growth in combination with CCS. And then overall, it's expected that primary energy, the role of bioenergy in the primary energy would increase from 10% to 20% overall. So quite substantial, and we see that transport and industry are really the main growth markets for bioenergy. Of course, this also needs to be related to how much sustainable biomass potentials that there are. So you saw in the previous picture that it was kind of stagnating to a certain level of bioenergy that we could use. This was an analysis from a few years ago on the different types of biomass that there are, and the potentials that were derived from literature also that could be available. So starting with municipal solid waste, renewable share of it. On top of that, you have residues, so residues from agriculture, residues from forestry practice, residues from industry also, which is kind of the most substantive part actually of this potential. Then on top of that, you can have additional forestry operations, so afforestation and really growing extra wood or really maximizing wood production. And on top of that, you can also have agriculture, where you're looking at lands which are currently not used or underused, and growing energy crops on those. That's quite a big potential, but it's also one of the more expensive options as well. So actually, the overall potential was then estimated around 140 exajoules of primary supply, and that was also used in the models from IEA. So kind of a message also there is that we need waste, we need residues, we need forestry, we need energy crops. So actually There's different sorts of different types of biomass and different types of sources where they come from. They need to be produced in line with sustainable resource management, so in line with sustainable forestry practice, in line with agricultural practice. So that is really the sustainability boundary also that we need to take into account. So also with minimized impacts on land use changes. So try to co-produce with food and try to use underproductive land and then also improve production. And also, of course, also supported with a general effort to improve agricultural productivity and have sustainable practice there and better efficiency, that we don't have so much loss also in the food supply chains. Now, recently there was quite some debate on the climate impact of woody biomass. I don't want to go very deep into this, but just highlighting a few points there. Because there's quite some misunderstandings also we see in this debate. So first, we need to recognize what I said before, that there are many types of biomass used for bioenergy. And in terms of woody biomass, you also have really many types of woody biomass, going from waste, from industry residues, from forestry residues, from different types of stem wood as well. Also wanted to remind that forests which are now under commercial management, they are really managed to provide multiple forest products. So the first priority there is high value wood, high value timber. And most of the wood used for energy is really a byproduct or residues or stems which cannot be used for this high value timber. And clear cut for energy is really not common practice. Any harvesting of biomass, and then I'm talking about bioenergy, but also for timber, for construction material, for paper, for other use. So it all should occur within sustainability boundaries. So we do stress the importance of sustainable forest management, which is actually a precondition also to be able to say that this is a renewable resource. Also often forgotten is that the CO2 from biomass combustion is part of a short-term carbon cycling. So what's often done is comparing CO2 at the exhaust, which is actually ignoring the balance that you can have with the uptake of atmospheric CO2 in plant growth. But of course, on the other side, you also need to consider what are the medium-term impacts on the carbon storage and carbon sequestration in the forest. So this can be negative, can be positive. So we really have to look into the practice itself. So I already mentioned that it is renewable if you maintain your forest productivity. So actually, it grows, you harvest, you grow. So it's normally under sustainable forestry principles. This is in balance. Of course, if you have unsustainable practice, and we do know around the globe that there is some unsustainable practice related to permanent deforestation, of course, this needs to be excluded from support. And just an overall reminder, so it's really, we can start with this at the short term. Well, it's already happening, can already increase at the short term. It's compatible with existing energy infrastructure, so you can substitute coal, natural gas or petroleum fuels already at the short term. So it's important in the short to medium term transition, but also, as you've seen in the IEA scenario, also on the longer term, like the combination with CCS remains important. Specific markets like industry and aviation also remain important. Okay, to come back to the industry part. So we had a workshop in October, so a few months ago, really specifically on industry transitions, where we had 3 sessions looking at different sectors and applications. So we first had a session on medium and high temperature process heat in industry, then a session on energy intensive industries, like the steel and cement sectors and potential role there of biomass. And a third was the chemical industries. So you see a link there with all the presentations and the summary. I think you will receive this presentation, so you're welcome to click on those links and then go look there. I just summarized some of the main findings of these 3 sessions for the different applications. First, about medium and high temperature process heat. So we already see that there's quite a number of fuel technology combinations which are commercially available. And there's already many successful examples of bio-based industrial heat. And in a lot of cases, in most cases at the moment, actually, it's based on the use of own process residues. So you have food processing industries, you have paper industries, you have food industries, which are using the residues that they have and try to produce heat from it, or in food industry sometimes in combination with biogas production. So this is more common at the moment. We also see that other small and medium-sized industries, which have quite a lot of heat demand internally, are looking into options to reduce the carbon footprint of their process. So also looking into biomass resources. And what's interesting for these industries, which are kind of medium scale usually, is that they can match a little bit better with the resources which may be available at the local level or the region level, and a link with local regional hubs as an interplay between the source and the user can be interesting there. Optimal combinations are generally very site specific, depending on what kind of energy you need, what kind of temperature you need, what kind of resources you have in the neighborhood. So that needs careful assessment. In terms of steel and cement industries, maybe this is a little bit small to read. Well, they are very important in the industry part. So the cement and steel industries represent more than half of the global direct CO2 emissions in industry. So important sectors to tackle. What's also important to say is that CO2 emissions in these sectors is not just from fuel combustion or for heat production. It's also linked to the industrial process itself. So in steel industries, you have iron ore reduction, which leads to CO2 emissions. In cement industries, you have limestone calcination, where the carbon in the limestone is also converted to CO2. So that's also a matter which needs to be taken into account. We had some presentations on steel making. There's an extensive use of coal there, both as energy resource and reductant. And options for bioenergy or bio-based is that you could replace some of the pulverized coal by biocoal from slow pyrolysis with existing technologies. So you could go up to 20%. There's also potential for lignin sources. So you can do something already immediately in replacing some of the coal use. Next to that, there's also opportunities for doing something with a blast furnace gas, which contains CO and CO2. We have seen initiatives, for instance, from ArcelorMittal, to convert this CO and CO2 into to fuels or chemicals. It's also interesting development. The cement sector is already using different types of what they call substitution fuels. So they're really looking into mostly low-cost fuels, and waste is a big part of that for their energy needs. But as mentioned, well, the limestone calcination process is pretty important, and 2/3 of the CO2 emissions are related to that process. So you can't just replace the energy by renewable energy. You have to do something with that process as well. So CCS will be really crucial for this sector. Now, overall, if you look into these energy-intensive industries, of course, they have big energy needs. They have big demands for coal at the moment, or other input. So the size of this consumption can be a bottleneck. Also, the access to biomass can be one of the biggest issues. So bioenergy can play a role there, but you certainly have to make combinations with other solutions like electrification, like hydrogen, like CCS, to further reduce the carbon footprint in these sectors. A few words on chemical industries, which we had in our third session there. Now the industries, well, most industries are cost-driven. So actually a switch to bio-based feedstocks, which was mostly the focus in this session, it needs to make economic sense. So either if it's more expensive to produce them, you need to have premiums for such products with a low carbon footprint, or a clear market pool from certain brand owners also helps. Of course, there are established markets, fossil-based chemicals, and one person said, well, this is, if you want to enter this market, it's like jumping on a moving train. So you're expected to have high product quality, production of scale, competitiveness from the start. So it's really not so easy to jump into that. What we also see, yeah, okay, yeah, I think I have one more slide after this. What we also see is that fossil resources, they are actually managed in refineries, so in synergy with all these processes where you produce fuels, chemicals in quite an efficient way, while this concept of refining is less developed for bio-based resources. So these are steps that we have to take. Another thing brought forward was that hydrogen really plays an important role also in bio-based industries. So green hydrogen can further improve the carbon footprint of bio-based products, but of course this is also valid for fossil products where hydrogen plays a big role. And one thing, so if there are already bio-based chemicals at the moment, like 15% of chemicals is already bio-based, mostly from vegetable oils or starch. But the sector is not really used to handle solid biomass. It also doesn't have the same feedstock quality all the time. So this feedstock thing and access to biomass is really crucial. And quite interesting is that we see forest-based industries which have access to certain sustainable biomass feedstock supply are stepping into this, and that's quite interesting. And I think there's a few players also in the discussion today. To round up, so my conclusions. So biomass is a key component to reduce climate impact of industries. It's one of the options that we need next to each other. So next to electrification, hydrogen, and CCS. Of course, we need to increase the awareness of that to industry and authorities, what's needed in these sectors. So industries need to look at the long term. So net carbon neutrality is really a focus at the longer term, and industries need to be prepared for that and take necessary steps to go there. The main challenge we've seen is really the low cost of fossil alternatives if there is no accounting of carbon cost. And we see that it's really necessary if there are sustainability advantages, both in terms of carbon, but also in terms of waste reduction, emission reduction, that this also needs to be reflected in economics, like internalizing the external costs. Availability and access to sustainable biomass is crucial to increase the role of biomass in industry transitions. And also have to take into account if there are competing uses or not. So the importance of mobilizing biomass supply chains, and you can have specific market strategies like brand owner pools, which can be applied for low carbon and bio-based products. So you need to have strong and credible green labels for that. Thanks for your attention, and I hope I didn't extend my time too much. So thanks.
You extended it slightly, but it was very interesting. So we decided not to cut you. There are a few questions, but these questions will be posted at the end of the event, not to interrupt its so to say flow. And thank you for your presentation. Very compact, very comprehensive. Few takeaways, at least for me, is that the sustainable bioenergy is in line with the climate modeling. It delivers GHG reductions, what we need. And both transport and industry will be the main sources of growth of the sustainable bioenergy in the future. And now we move to another presentation. Eduardo Sembrano, you can share your screen. The floor is yours. You have 15 minutes. You can start.
Okay. So good morning, everyone. Can you see my screen?
Yes.
Okay, perfect. So first of all, I would like to thank Bioenergy Europe for inviting us to this great event. My name is Eduardo Sembrano. As Michal said, I'm the director of the Industry and Energy area in CIRCE. And I will try to explain a little bit about the industrial cases of the bioenergy use where we are fostering this kind of technologies in the industry sectors. So as Mr. Beckmack said, there is a great potential in the use of bioenergy in the industry. So I will try to deepen a little bit about what we are doing there. So firstly, let me start with a small pill of who we are. So Circe is a research center created 27 years ago, and our mission is to improve the competitiveness of companies and the industry by generating and transferring technology through market-oriented R&D activities. So our main business lines are renewable energy, electrical grids of the future, smart mobility, Industry 4.0, energy efficiency, and circular economy and sustainability, which will be the topic that I will be talking today. So we are more than 200 employees, and we've been working in the bioenergy use for such a long time. So I will go directly with the projects and cases that that we are involved. So firstly, let me talk about REFO Industry Project. This stands for Renewable Energies for Energy Intensive Industry. This is an Horizon 2020 project funded with 3 million euros. We are 11 partners working together, academia, R&D entities, and industry represented as well. So the main objective of the project is to facilitate a transition to the adoption of renewable energies in the production processes and facilities in the energy intensive industries, and how we are going to do that. So we are trying to guide these sectors and their sectorial organizations in their path for a total decarbonization towards 2050. And we are providing vision and guidance to establish the long-term strategy and the short and medium-term strategy to facilitate the integration of current and future renewable energy solutions. As per the specific goals, I won't go into details, but we have an holistic approach. So we will set a multi-actor collaborative network. We will show the renewable energy technologies with more potential to be used in the short and long term. We will share success stories. We will try to empower the sector and key organizations, and we will grow interest and alignment of the European society. And we will put our effort to achieve a common understanding and vision of the role of these sectors towards this 2050 transition. This is the overall concept of the project. So the first step for an effective transition towards carbon neutral production is the adoption of currently available renewable energy solutions, but without disregarding the long-term transitions. So here you can see what we are evaluating, the roadmap towards 2030 with, let's say, more current available renewable energy heating solutions such as biomass, bioenergy carriers, solar thermal for high temperature and geothermal technologies. And the roadmap for the long term, considering new renewable energy solutions, hydrogen, syngas, and e-fuels. In the end, what we try to do is to empower big renewable energy consumers and make them understand their new role and position towards this technology integration. These slides allows me to explain a little bit this holistic view of the project. So the main target of the project are this energy intensive industry, but also the sectorial organizations and the business organization which represents the interest of the sector. And in the end, of course, we have to take into account the EU market and international trade, where these industries exchange goods and services. And obviously, we are considering the framework regarding the local communities, the society at national and European level, and the policymakers to foster an adequate regulations to the best integration of these technologies. In the end, we are trying to contribute for this expected impact. Again, I won't go into details, but we are talking about an and an improvement on 3.5% of annual share of renewable energy. We're talking about the creation of 8,000 new jobs. We are talking about savings in CO2 emissions equivalent between 340 and 150 million of tons by 2030 and 2050. And the REFOR industry is fostering and accelerating the technologies and the integration of these technologies to achieve these impacts. Then finally, I'm going to explain a little bit about a couple of projects where we are working with specific industrial cases. I will deepen a little bit about the solutions that we are working on. So firstly, we have the project Retrofit, is another Horizon 2020 project funded with nearly 10 million euros. We are coordinating the project, and as you can see here, the industry and end users are quite well represented here. So we have Cecil, Lasas, Pitini, Fertiberia, Tenaris, and so on. So the main objective of the project is to enable the use of an increasingly variable bio-based and circular feedstock in process industry through the retrofitting of core equipment and the implementation of an advanced monitoring and control system. The represented sectors here are ceramic, cement, aluminium, steel, and agrochemical. So we're starting with the cement sector. We have Cecil in Portugal, and the main objectives here is to improve the plant environmental performance by using bio-based feedstock, to increase the knowledge about the process conditions and feedstock characteristics, and to replace in a percentage traditional raw materials. Of course, we are considering the availability, prices, and market trends of biomass costs and pretreatment costs where the pretreatment stages are needed. So as you can see here, we are evaluating internal waste and alternative feedstocks, which could be provided by external companies. We are evaluating waste tires, solid recovered fuel, and different types of biomass. As you can see here, agricultural, forestry, and other alternative biomass resources. As my colleague explained before, so we have to address different type of solutions for the complete decarbonization of the sector. So we are evaluating these different solutions, which should be sustainable in terms of the environmental aspect, but also on the economic aspect as well. So this is the second demo case that we have is represented the steel industry by the company Feno in the north of Italy. Again, we're trying to achieve a local and sustainable supply of raw materials for the production of high quality steel, to demonstrate an economically feasible ways of using bio-based raw materials in the steel making process, and to reduce the emission of the plant by means of a single solution. Here, as you can see again, we are evaluating internal waste to use such as black and white slag, rolling mill scraps, and dust from the electrical arc furnace, and we are evaluating as well alternative feedstock such as waste plastic grains and biochar coming from existing suppliers, or we are studying the development of a new installation near the industry to foster these solutions. So in the end, what we are trying to do is to replace these anthracites used in the furnace by bio-based materials and sustainable raw materials. And finally, we have Fertiberia, which is represented the agrochemical sector in Huelva, Spain. Here we are trying to achieve an alternative supply of material that enables the industry to reduce its dependence on foreign raw material supply, to take advantage of byproduct streams by obtaining new and alternative raw material sources from them, and to reduce the consumption requirements from the treatment of alternative sources. Again, we evaluate internal wastes, we evaluate alternative feedstocks. In this case, we're trying to substitute compounds and minerals that are needed in the agrochemical, in the fertilizers process. So we are talking about phosphorus, sulfuric acid, ferrous sulfate, ammonium sulfate, and potassium. And we are evaluating ashes from biomass combustion, from meat and bone mills, from estruvate and digestate. So as you can see, in the end, what we are trying to address is not only the substitution of the raw material itself, but we are evaluating the whole value chain, the supply chain of the material, the internal waste, the operational consideration of the processes, and all these aspects should be taken into account to address a sustainable solution. As per the impacts, as you can see here, we are not evaluating only greenhouse gases emissions and the reduction of fossil fuels and the energy efficiency, but also the operational expenditures and the improvement of the productivity of the plants. And finally, our last case is we have different energy intensive industries in bamboo project, which again is a Horizon 2020 project funded with 11 million euros. Again, what we're trying to do in this project and in all the solutions where we are involved is to consider the industry needs from the very beginning of the design of the solution. That's why we have Sidenor, Magnesitas de Navarras, Grecian Magnesites, Tupras, ArcelorMittal here in the consortium, so that we are able to consider their considerations and their needs from the design stage of these solutions. So the objective of the project is to demonstrate innovative technologies for waste heat recovery, electrical flexibility, and waste streams valorization. I will focus on this last topic. And we have here petrochemical, paper and mineral, and steel sectors. I will focus on the mineral sector today regarding the bioenergy solutions that we have in our hands. So in the end, we are aiming at reducing fossil fuel dependence and NOx emissions in the calcination process of the mineral sector, replacing coke with biomass, analyzing again availability, prices, and necessary pretreatment steps for such biomass. And regarding operational considerations, we are designing the adaptation of current burners of the kiln to keep the high temperatures required to the process and to lower these NOx emissions. We have Magnesitas de Navarra again for this sector. We are replacing coke by biomass, and we are trying to enhance the flexibility of the operation. So we're investing in the simulation of increasing pet coke storage capacity in the silo to enhance flexibility. And we investing in designing a biomass logistics center to valorize the forest residues around the industry in Navarra, which is the region where Magnesitas Navarras is placed. These are the expected impacts in the mineral sector. We'll go through the first point. So taking into account only the fossil fuel substitution by biomass in the project, we are trying to reach savings up to 19% in energy and CO2 emissions, up to 14% of energy cost reduction, and up to 35% of NOx emissions. Again, only considering the substitution of biomass by this, the fossil fuel with this biomass. That's all from my side. I hope these industry cases are interesting for you. If you have any doubt, I will be pleased to comment it in the Q&A session at the end of the day. Thanks.
Thank you, Eduardo. Thank you as well for keeping the timeline. So after these two presentations and theoretical part, we can move to panel discussion. So our three speakers, Mikael Jugaste, Renewable Invest, Anna-Liisa Myllynen, Stora Enso, and Karita Olikainen, Valmet Corporation. So in this part, I will kindly ask you first to present yourself, your organization, explain us what are your connection to the use of the sustainable bioenergy or the value chain of the bioenergy use, and also referring to the main points of today's discussion, so decarbonization, circularity, and strategic autonomy. Also, you can refer to the information presented in the previous presentations. And first, I kindly ask Mikael Jugaste. In the meantime, I will share the screen.
So good morning, afternoon, everyone. Thank you for having me. My name is Mikael Jugaste. I'm from the Renewable Invest Group. I work as the head of quality and certification systems, overseeing our sustainability and environmental performance, as well as certification. Our group is mainly a bioenergy producer and generator, but we are also very actively developing sustainable supply chains, meaning mobilizing biomass that is already available but not used, and developing biomaterials, let's say, aspect as well. We operate pellet plants in Baltic states as well, one in the US, Texas. We operate 6 combined heat and power plants, which produces our own renewable energy and our neighbors, as well as we sell to the local grid. And as I mentioned, we have a biomaterials demonstration plant where we aim to develop bioprocesses and non-energy applications of the lowest wood feedstocks available. Our model or concept is simply operating within or in close proximity of wood-based industrial parks, which this essentially means that we are within an industrial park which is a successful example of a working bioeconomy where mechanical processing, chemical processing, and energy generation is all done on site in close synergy. What this means is an industrial park where we also operate in already produces sawn timber, solid wood panels, biomaterials, biochemicals, pellets, and heat and power on site, sourcing from a 60 to 70 kilometer range, but independently generating all the energy needed for it to process its products, give the highest value to all the material that reaches that industrial park, and also autonomously providing renewable energy to the regional grid. So what is important to take from this is that these industrial parks as successful bioeconomies already exist. They are a very good example for the rest of Europe as a sort of zero-emission, closed-loop, autonomous industrial solution where all feedstock has given the highest potential value on site. Everything that is convertible to non-energy products is done, while everything that is not convertible is on site produced to energy, which supplies the industrial park itself and the regional local grid autonomously by only sourcing from a 60 to 70 kilometer region for feedstock. So leading into this today's panel, I would like to sort of highlight our concept as already available success story of a circular bioeconomy where the highest percentage of material is kept as mechanical products that store carbon and decarbonize the economy. Therefore, they act as an autonomous unit by autonomously supplying themselves with energy and the local grid with green energy. And these examples are a very good example of available renewable energy success stories that actually should be duplicated right now across Europe. But for some reason that is not done today, and as a lot of resource potential is missed. I will stop there. Thank you.
Thank you, Mikael. Very compact, also very informative. Now we move to Anna-Liisa Myllinen.
Thank you and hello to everybody. This is Anna-Liisa Myllinen speaking from Stora Enso's division Wood Products. As many of you know, Stora Enso is a renewable materials company manufacturing biomaterials, paper, packaging materials and wood products. In the wood products division, we serve building sector with wooden building products and also technical solutions. In particular, we manufacture CLT and LVL based building solutions, but also anything from classic sawn timber to engineered wood. Secondly, we are also manufacturing wood pellets for industrial and residential customers. And our pellet mills operate in the integrated environment with our sawmills and other wood products mills. So we have an integrated concept here, and we can avoid all extra transportation of the materials. The wood pellets are made from sawmill residuals, sawdust, and shavings, and they complete our product portfolio. For us, manufacturing of wood pellets makes sure that we utilize the available harvested wood about 100%. We have a full yield of all the wood that we take in, and there is no wood waste. In the same time, we can help substitute a big volume of fossil fuels among our customers. And also we are a big user of bioenergy ourselves. Tree bark is utilized in our boilers, in our mills, and almost all on-site heat is generated from biomass. So we can say that we operate in a pretty circular bioeconomy today. And like Eduardo said in his presentation, I think a holistic approach and looking at the life cycle impacts of the materials and energy is very important today, and trying to minimize the life cycle carbon emissions and fossil carbon emissions and other environmental impacts. So life cycle assessment is what we base our developments on. And to summarize our operating principle, we use the available wood resources to produce the highest added value products, highest value to the society, and in the spirit of circular economy, we utilize the process residuals for bioenergy. Thank you.
Thank you, Anna-Liisa. Also, thank you for being very precise with time. And now we move to Carita.
So thank you. So hello, everyone. My name is Carita Ollikainen, and I'm the head of corporate relations at Valmet. Valmet is the leading global developer and supplier of process technologies, automation and services for the pulp, paper, and energy industries. And our mission is to convert renewable resources into sustainable results. And I think that this describes very well the business that we are in. A couple of words about Valmet still. Our net sales last year were about 3.7 billion euros, and we have over 14,000 employees operating globally. Half of our business is what we call capital business, meaning technologies for the pulp, paper, and energy sectors. And the other half is what we call stable business, meaning services and automation for our customers. Our largest market is the EMEA area, with last year that was 39% of our turnover. But second was China with 24%. We are very happy to have a leading market position in all the markets that we operate in. And sustainability is a very valued thing for us. And we have been, for example, in the Dow Jones Sustainability Index for the past 7 years. We also have a -A rating in CDP climate program last year. But if looking at the bioenergy sector and what we do there, so we provide technologies, meaning boilers and gasification plants, and then also emission control technologies for our customers. We also provide them with services and automation, so that they get basically the very comprehensive package from us if they so wish. Over the years, we have produced for our customers over 270 fluid bed boilers. These are CFB and BFB boilers, over 400 environmental systems, meaning these emissions control technologies, 8 gasifiers, and over 100 marine scrubbers for boats. And if looking at these FB boilers that we have sold over the past 30 years, and excluding those that use waste fuel, the energy produced in them with renewable fuels equals to 1,560 terawatt hours. And if assuming that this amount of energy would have been replaced with coal firing, we would have avoided 467 megatons of CO2. Thanks.
Thank you. That's really impressive number of avoided emissions. Thank you, Carita. And now let's move to first question to Mikkel. As you described, Granul is a large international company producing pallet and involved in general in forestry sector. But it's also important to make a point that the bioenergy sector is very innovative, and you are investing a lot in innovative bioprocesses. Could you tell us more about how do you approach the integration of different outputs, biochemicals, biomaterials within your operations, and at the same time improvement of the circularity?
Thanks, Mikkel. Well, as a company whose feedstock is essentially the leftovers of existing wood industries and forestry industries, we need to be innovative and make sure that all this material always is given the highest potential as an application. So we have mapped some potential and technologies where we can give our local hardwood species higher value, potential higher value outside of the energy sector. We are happy to have first positive results from our demonstration plant. But essentially, this step gives us additional way to cascade material internally, like in quality, so we can first screen how much is convertible in a biochemicals plant. Whatever is not convertible can be turned to wood pellets, and what is not suitable for wood pellets is then generated into energy in our heat and power plants. This way we can always make sure that the highest % of material that we receive already in the lowest quality class is still given the potential, highest potential if that exists. But this process has also shown us that all material is not convertible to non-energy products. even more highlighting the importance of bioenergy, because what is not convertible to bioproducts in the biorefinery is still going to the bioenergy, and therefore this loop is sort of guaranteed to be complete. And of course, bioprocesses are very energy-intensive processes, and therefore our demonstration plant already in a smaller scale requires a lot of on-demand heat and power, and therefore that also highlights that these higher value processes and development of them requires on-site bioenergy generation. I'll stop there. I hope I answered it.
Thank you. Yes, totally. If audience has additional questions, don't hesitate to put it in Q&A box. And now we move to Annalisa. Could you please describe how do you work in such complex value chain? At least it is complex, at least from our perspective, when there are a lot of different residues and different environmental sustainability issues. And could you describe synergy between the use of sustainable bioenergy and improvements of circularity and resource efficiency of your company, and what sustainability impact it has had so far?
Thank you. This is a good question, and I would say that for us the value chain is actually pretty flat, and this is one precondition for being efficient and circular and avoiding excess emissions. The integrated production in our mills, where the biomass production is integrated with wood products, manufacturing is rather important, and also our own supply organization, which is supplying the wood to us from very short supply chains. On the other hand, our customers are residential customers who use wood pellet in their homes, or they are energy companies who are using wood pellet to produce electricity and heat. So from our perspective, this is rather efficient and integrated system, and of course it's developing and evolving all the time. So I see a future where we are even more efficient and where we can even more avoid fossil emissions and minimize all the transport, for example, to avoid any excessive emissions in the value chain.
Thank you, Annalisa. I think also it was very comprehensive answer. And now we move to Carita. And as you described, Valmet is one of the leading manufacturers of the bioenergy equipment, both in the EU and on the other markets, like in China. And from your point of view, what is your view on the so-called strategic autonomy of the EU industry, which was one of the key terms of the industrial strategy of the EU? How resilient is the EU in the field of bioenergy industry? And concerning the relaunch of the economy after COVID-19 lockdowns, how your sector of industry can contribute to the green recovery of the EU?
Thank you, Michal. The term strategic autonomy is not very clear, but from our point of view, this relates to the competitiveness of the sector. And as we all know, bioenergy is the most widely used form of renewable energy, and the European technology producers are really the global leaders in this field. For example, according to McCoy, if we are looking at fluidized bed boilers, which is the boiler type where biomass is typically used as the only or main fuel. So in the past 10 years, European producers have been responsible for about 83% of the new awarded capacity globally in boilers that are larger than 20 megawatts. And then if looking at all boiler types using biomass as a fuel, European producers were responsible for about 40% of the new awarded capacity. So based on these figures, I think it would be fair to say that the European bioenergy technology producers are larger than their size and that they contribute quite well to the strategic autonomy of the EU industry. And through new investments to sustainable bioenergy production, the sector is also very well positioned to contribute to the green recovery of the EU economy. But this presentation slide that I have here, it includes important factors for the sector's global competitiveness. And I would like to open this a bit more in detail because these reply quite well to the questions that you posed and also set some expectations from our point of view towards the European Union. So first of all, if looking at competitiveness, we're very lucky in the sense that the global megatrends support our business, meaning that there's a resource efficient and clean world, there's digitalization and new technologies, and also urban, responsible and global consumers. But secondly, we at Valmet, we have a long history in symbiosis with the pulp and paper sector, with companies such as Stora Enso. And there has been a need with our customers to efficiently use all the residues and side streams from pulp and paper making. And one of these uses has been energy recovery. So this symbiosis that we have had has enabled us to develop and grow our expertise in bioenergy and to expand our customer base then further. Thirdly, then, in the Nordic countries where Valmet comes from, we have been able to enjoy an enabling operating environment for a long, long time. We're talking about centuries. Valmet is already over 220 years old. So the Nordic countries have been sustainably using economic forests to create jobs and well-being. And this has enabled also the technology companies such as Valmet to develop and grow and to expand their operations also geographically. In the European Union, we have also enjoyed a good supporting environment with the trade agenda, supporting free trade and multilateralism, which have certainly benefited our sector. And the launch of the first Renewable Energy Directive was also an important supportive action. The lesson to draw from this is that the European bioenergy technology sector in many ways is as competitive globally as the bioenergy sector here in Europe. Policies and legislation here in the EU therefore influence our competitiveness and also our future in other markets. But fourthly, we also need a strong home market supporting R&D and demonstrations. So we compete in the global market with references, and this we get through demonstrations that we make in our home market. So for demonstrations, public support is typically needed, and their national and EU level actions are in a key position. But fifthly, then, over the years, we have been able to develop high level of technological expertise and know-how in bioenergy technology. And let's be clear, we do not compete in the global market with low cost or bulk products. It's our skills and technologies that we have developed that make us strong. But the competition is growing, and therefore the importance of securing high-level university education and traineeships in the sector is very high. And of course, it should be noted that we operate close to our customers, and therefore we have invested in sales, production, services, and supply network globally. And this increases our understanding of our customers and the ability to serve them. And therefore, our products are typically not exported from Europe to other regions except for some critical parts. And therefore, looking at trade statistics does not really give an accurate picture of the sector. It should be noted, though, that a large part of the value added remains here in the European Union, for example, through high quality jobs in technology and engineering. And for Valmet, then the last point is that we have been, the key differentiating factors is from the competitors is our strong offer, meaning technology, automation and services. Thanks.
Thank you, Carita. It was very interesting, adding also this global perspective. And we encourage participants to ask questions to our panelists. And right now we move to another question, which will be the same for all the speakers. You mentioned, we'll start with Michal. You mentioned, Carita, the so to say the importance of enabling framework and some kind of supportive framework for the development of the business. And in this regard, I would like to pose this question to you all: how to go beyond business as usual? What incentives are needed to exploit the described potential of sustainable bioenergy in the industry? And what would be legal certainty or more clearer dates of fossil fuels phase out, or financial incentives? So I'm really curious of your opinions. Michael, floor is yours.
Thanks. Well, yeah, that's $1 million question. I would say the core issue is that available bioenergy sources are today compared to future renewable energy sources which don't really actually exist yet. Whereas the comparison still should be made between the existing renewable energy sources like bioenergy and the currently existing fossil energy sources. So the comparison, although we need to be ambitious and think about the future, we've one step too far already, giving political advantage to renewable energy solutions that don't exist to scale. So in order to sort of give us a structure or give more stability or certainty for bioenergy, I think the legal certainty of sustainable biomass must be sort of stabilized, and all fossil fuel phase-out dates should be made clear, with, in parallel, highlighting which renewable energy sources will be unit by unit replacing those fossil energy solutions. So in that way, if we have that map set out in a more structured way, where a fossil phase-out unit of energy is compared with available renewable energy source in the same net unit, this would actually, I think, highlight again the importance of bioenergy and the other available sources, and would bring this sort of political support and incentives back from the future to focus on what is needed to do today. And these examples, like the industrial parks I talked about, good examples like Valmet and Stora Enso. These are the case studies that have to be actually duplicated and used today and supported, not something that doesn't exist or potentially won't exist. So that's my answer. Thanks.
Thank you. So focus on existing solutions, cost competitive solutions, legal certainty, and clearer timeline of fossil fuels phase out. Thank you. Another Annalisa, the floor is yours. The same question for you.
Okay, thank you. I think that the keyword was already mentioned here earlier, and that could be the cascading use of wood, which means that we are creating the highest possible value from the raw materials that we have available for the business and for the society, and having the right energy mix also in place, putting the right type of energy in the right places. And this could give us the highest possible resource efficiency. And when we are assessing the resource efficiency, it's important to look at the entire life cycle aspects and efficiency, and even several life cycles maybe, and also to compare with the alternatives, for example, between the wood-based value chains or fossil-based value chains, comparison of the alternatives, and looking for the most climate friendly and efficient options. Thank you.
Thank you, Annalisa. Cascading use of wood, some kind of clarity concerning right energy mix, and this, let's say, more critical assessment of alternatives. Thank you. And now, Carita, the floor is yours.
So from Valmet perspective, it's a combination of all that you mentioned, Michal, and also a bit more. So we definitely need a stable and coherent and long-term regulatory environment, because investments made to our technology means investments made for at least the next 30 years. So therefore, investment certainty cannot be emphasized enough. And then for the same reason, we also need clarity on sustainable biomass use and its role in decarbonizing the European Union. So for example, the sustainable bioenergy criteria in the Renewable Energy Directive and the criteria in the new sustainable finance taxonomy, they need to be aligned, as double standards and differing interpretations on what is sustainable would certainly and effectively work against the sector. We would also be happy to see the political discussion reflect a bit better the realities of the market today. So for example, we hear a lot of criticism towards coal-firing, but the market is no longer in the market. This no longer really means automatically the use of coal. Our customers, for example, are increasingly seeking solutions for combusting waste with bioenergy. So this would be a resource efficient and good use of the investment made. And in our view, developments like this should be endorsed rather than something else in the political discussion. Of course, you mentioned the fossil phase out, so clear dates here would not hurt. But from a technology developer and developers and providers perspective, what is, I would say, even imperative is that the European Union takes good care of the competitiveness of the bioenergy technology sector. If we are not competitive, there will be others who will be happy to take the lead in the market, and their solutions will not necessarily be as sustainable as ours in Europe. The European bioenergy sector, technology sector, is in a good position to contribute towards the decarbonization globally and not just in the European Union. And while doing this, the sector will create high quality jobs, value added, and well-being in the European Union, and also jobs and well-being in other parts of the world.
Thank you, Carita. Just one question I cannot resist. What is your point of view on carbon burden adjustment mechanisms? Because I know that you are quite interested in this tool, and what the market and the business thinks about this sort of solution.
Well, we have quite strong reservations on this, and of course we don't have a proposal or a text that we could dig into in more detail at this stage. But the reservation comes from the point of view that even today we are able to produce technologies for our customers in different parts of the world, and the cost competitiveness is quite high. It's not just European companies making an offer to a customer. It's also technology providers in other parts of the world, and if it goes, the margins are very small. So if costs are going to be raised here in Europe, we already today have to evaluate where we produce the technology. So probably this, in the worst case, would not be produced in Europe anymore. The production would be directed in other parts of the world. And this would mean that we would lose those jobs that we have here in Europe. We would lose that high level expertise at some stage. And we don't think that this would be necessarily a good development for the bioenergy sector or the manufacturing sector in Europe otherwise. So we say that if there is a proposal, we hope that it's well balanced and takes into consideration also the role of the globally operating companies that are here in Europe today and also in other parts of the world. So it's not a separate decision to start manufacturing elsewhere. We have that system in place already today. We come from Europe. We would love to continue manufacturing here as well, but the realities of the market will dictate the outcome. So, thanks.
Thank you. Reality of the market will dictate the outcome. This is nice takeaway, I think. And thank you for this second round of questions. Now we move to the last part of our event. But first, we'd like to launch a second poll. I know that the whole industry is well represented in the audience, so I'm really curious of your opinion about the Yeah, about the question. So what measures can incentivize the development of the sustainable bioenergy in the industrial sector, taking into account all the arguments you have heard today? Supportive regulatory framework, financial incentives, or improved availability and sustainability of the biomass production? 1 minute for an answer. And then we move to Q&A. Okay, thank you for all the votes. So the supportive regulatory framework, 44%. So this is what basically we try to influence as a Bioenergy Europe here in Brussels to facilitate the voice of the European industry. And of course, I will take this opportunity to invite all the other organizations to join our associations. Of course, if they are interested, it's for us always easier and more representative to have more members and to torch the position towards the European institution. Then financial incentives and also the second most popular answer was improved availability, transparency, sustainability of the biomass production, which obviously is a priority for the industry, and financial incentives third. So I think this also reflects that the bioenergy technologies are cost competitive and the financial incentives are least important than other aspects. And now we move to Q&A. I give the floor to Julia Kanchan, Policy Director of Bioenergy Europe, and she selected several questions among one post during the event. Thank you.
Thank you, Michael, and good morning all. So both the chat and the Q&A questions were. I would like to thank first of all Luc Pelkmans, as he answered most of the questions in the Q&A box already. Just to summarize a little bit, most of the debates and the questions were focusing on the sustainability and the circularity aspects. On the circularity in particular, some questions were underlining the possible competition of uses. Maybe I will ask briefly to comment on this to Annalisa and Michael, considering their the main business of their companies. But I will, before everything, I will start with a question for Eduardo. This question is from Felipe Rodriguez. He's Portuguese. Well, he's Portuguese and he works for a Portuguese agro industry in extra virgin oil, and he asks whether agro residues such as olive cake can be part of the solution for generating bioenergy and other purposes to promote carbon neutrality by 2050, and how this can be incorporated. Eduardo, the floor is yours.
Yeah, thank you, Julia. Could you repeat me the exact material that he mentioned? But I lost it.
He's speaking about olive cake. Mm-hmm. So yeah, an agro residue basically.
Yeah. Yeah. Okay. Yes. I mean, so again, we are trying to first to analyze what is already available in let's say around the areas of the industry, and how to build sustainable value chains for that, because sometimes the logistic is an issue, sometimes the economic of the business model is an issue, and sometimes the operational parameters is an issue. So if I can maybe share some examples of agricultural, not agricultural biomass that we are evaluating. So we are We are evaluating something, certain materials like palm nutshells, rapeseed stems, sugarcane bagasse, sugarcane leaves, of course, straw, but also we are trying to use residues just considered as non-agricultural biomass, such as animal fat, dung, meats and bones, and other degradable wastes. So in the end, it's not only about that is technically feasible, I would say, but also that it's available in the area near the industry, because what we have been addressing in the last years is that the non-technical barriers are quite important in this supply chain of bioenergy use and biomass. And so if we are able to put together all the stakeholders in the value chain, of course, and if this is economically viable and sustainable for the environment, for the region as a whole, is quite easy. Let's say it's easier to start a value chain like that.
So thank you, Eduardo. Indeed, the non-technical barrier are quite important, and logistics is key to ensure availability. I will pass to another question. I will pose it to both Mikkel and Annalisa. What are you giving back to the forest ecosystem, taking into account your business activity? This is a quite wide question, and you can really decide the angle of your answer. Maybe Annalisa first.
Yes, thank you. If I hear you correctly, it's about the forest ecosystem, and I would say that the developments and all this potential and capacity that has been put to the development of sustainable forest practices and will be put into the continuous development of sustainable forest practices. If I keep this short and summarize it this way, so I think this is what the bioenergy sector can give, because it of course increases the efficiency of the resources used and creates the positive potential in also looking at the sustainability in the resource base.
Thank you,
in a short way, this way.
Thank you, Annalisa. Mikkel, maybe a comment on this?
Yeah, thanks. I think, I will build on Annalisa's comment that we will provide sort of the motivation and additional finances for more forest owners to participate in sustainable forest management, and actually that they will be encouraged to manage their forests despite the current state they're in. So a forest that is in very poor condition, or a forest that has a sort of a monocultural forest cover, will be converted to a multicultural healthy forest that is managed regularly. And in order for a forest owner to do that, they need to be able to know that they will receive some income for also the underforest and the lower part of their sort of first harvests. And if that sort of 30–40% income is taken away from them, on top of the sort of higher value products, that they might not be afford to manage that forest at all, and therefore be motivated to not do it.
Thank you, Mikkel. I will pass it maybe to Mikkel to draw some conclusion. I think that we are getting towards the end.
Political issue and more energy security issue, and at the same time support the decarbonization of the European economy. So thank you very much for your questions. Also, thank you very much for all doubts, because the dialogue is essential, and only through dialogue in a respectful and fair way we can demystify certain practices and also improve the sustainability of the processes, of bioenergy processes. We believe that this is the solution for the future, and we have arguments to present them. And once again, thank you for our panelists, and thank you for your participation. Goodbye.